All right, let's just get started. So, hi everyone, thanks for coming out to the workshop here. I'm Steven, and I'm with Cyber UCI. I'm the recently voted in president of the club, and I'm here joined with Akshay, who is one of our competition co-leads on our A board. And today we'll be giving just a short intro into the wide field of application security and kind of discussing it in the context of how it applies first to your hackathon projects and how it is more widely applicable if you are planning to pursue a career as a software developer. And just the agenda of what we'll be going over, just an intro to our club and us, explaining what is application security exactly, then talking about how does all of that then apply to you. We'll be giving a quick demo of a popular application security tool that you may even see in your internships and full-time careers at some point in the future. Talking about some resources you can refer to for application security, and then talking about some kind of big key takeaways of what you can do right after you leave this workshop. Now, what we're teaching here can be used illegally, so we do have to put a disclaimer because you may notice that it can be pretty simple to execute out some of the stuff that we'll be talking about. And so just to kind of cover what we're talking about, what VenusHacks here, and making sure no one here gets arrested. We're just adding this disclaimer so that hopefully you don't do anything illegal. And we do recommend that if you would like to practice these, do so in a safe environment that is your own code or computer.
So quickly, we are covering UCI for the leading and actually only resource for campus, and we kind of promote the idea that anyone regardless of any skill level or any background can get involved in cybersecurity and learn more about it. And we do that through three ways. One is the workshops that we use every week that are again friendly and introduce various security concepts. Some stuff we did this quarter was AI happening in the quarter. We talked about firewalls just last week. We also compete in security competitions, and these security competitions involve us defending against hackers in time, keeping our servers, doing stuff that you see in jobs, and also various applications.
And we do have our own dedicated lab space. If you ever want to come by, come to our workshops, ask questions, get to know some of our club members so that you never know, expand your network. We are located in ISEB on the first floor by the Garbanzo. You can always join our Discord later just so you can get more information on that.
Quick plug, we compete as a national competition. We recently did very well and finals. It's second in regional, historically dominant schools, like Stanford University, national finals. Hoping to go back next year. And we're always looking for people to get involved. We're currently running through it right now.
Yeah, and highlighting how some of the school has recognized us. That headline is from one of the news articles made by ICS communication staff. And that's featured on, or to your left there, that's our teammates, or that's our whole team, and featured on UCI's experiential learning programs Instagram. And so today, what we're hoping to do is to first exactly define how application security, or define what it is, and then contextualizing it for your projects and in future encounters. We're going to introduce some common tools, resources, and frameworks for application security, and just bringing overall more awareness to cybersecurity in the context of software development. And so what is application security? And going into it, something that you should know is, as a software developer and just an engineer who's building something for the general public, you have a responsibility, and often it is law, to properly protect the users and consumers' information. So may that be your users who sign up for your platform, whether it's their passwords, credit card information, their other personal information like addresses, even age, date of birth, social security number, and so on. And within the software engineering tech industry, the goal is right now to shift security left within the software development lifecycle. So what that means is security has often been overlooked to be more of an afterthought in many people's projects. But now we want to be starting to thinking about security from the very get-go, from right when you're gathering requirements from your clients, from when you're designing your software's architecture, or from when you're working on an idea in a hackathon. And first, why cybersecurity in general? Well, the cost of a data breach that you may see common in headlines in CNN, ABC News, all those mega news channels, you often see X company has been hit with a data breach. 45 million users' accounts have been leaked. And the cost of that has been estimated to be, on average, close to $5 million USD. And that's every time a company gets hit by just a hacker getting in and being able to leak some information about their customers. You also want to aim to create trust from your community and the customers. And you really want to avoid having a massive PR disaster when a breach does happen. Often that you can kind of equate a drop in a company's financial stocks with a headline that says their company has been hit by X hacker organization. And again, security is a complex issue, but at the end of the day, it is still a necessary, I guess, evil to tackle, considering the amount of people out there who are willing or who are wanting to break in to make as quick of a buck as possible. And most importantly, you do need to have some security mechanisms in place, because there are laws and regulations out there, whether that's at the state level or at the federal level or even international level, that you have to comply with so that you can do business within the United States, within Europe, within California even, and all that. And you want to make it, the goal is that you want to make it difficult for hackers. It is a pretty, what I call an asymmetric game, where that while you have to be on the ball for 100% of the time for hackers not to get in, they just need to find one way in, and that's kind of how things start to crumble. But that being said, you do want to limit how they can get in and what they can do once they're in there, right? So anything's better than not having anything at all. So you can see, kind of within our generation, there's been a rise in deepfakes as a cybersecurity incident, where what people are doing is that they are creating, say, deepfakes of, or making like just AI generate content that is impersonating an employee or the CEO, other high ranking people, to try to get employees to click on something. And that's usually how the cookie crumbles and stuff like this. Healthcare is a common target for a lot of hackers out there. In this case, the United Health CEO had to pay a $22 million ransom to get their systems back to normal. A vet firm was hit. That's pretty a low blow, honestly, because why mess with pets? And even big companies like Uber are hit. And they didn't give too much information, but this was pretty recent. And so it goes to show that the wide spectrum of things out there are being hit, whether it's your local vet firm, your local hospital, or even your international mega corporation like Uber. Now, this is a definition of application security that I pulled from Sneak, a leading company that does application security work. And I highlighted the critical parts of it. But basically what you are doing when you are, say, doing application security related tasks is that you are identifying, fixing, and preventing vulnerabilities within your software. The other main part of it is that you are creating processes and frameworks in place for your own software or even your entire organization so that you can have a secure software development lifecycle. And the bullet parts of the integrity, confidentiality, and availability are just some of the common pillars of what it means to be secure. And I've been mentioning the software development lifecycle a good amount. And you may have seen it in your coursework already. And this applies a security spin to it so that, again, from the very get-go, when you start building out software, you want to be thinking about security either by, for example, at the design stage, you're thinking about what possible attacks can happen. When you're doing testing, you want to be testing both for functional stuff and for security stuff. When you commit a change, you want to make sure that that change did not break anything and as well as cannot be easily broken by a hacker. And then after you've gone and published your work out there, your websites or platform is now available for the public. You then want to be continually testing it as much as you can so that in case that a hacker were to find something loose in there from a recent committed change, then that can be caught ASAP before someone else can do something malicious with it. And so for application security, some of the common tasks that you will be doing within that area is, again, the modeling part of it, so that you're determining what possible threats are viable. The main one is that you are either manually reviewing code or using automatic tools to scan for security vulnerabilities. Even as a software developer, you may not need to know every possible threat or vulnerability out there, but you can at least use a tool so that you can have it get fixed for you. You may be developing automated checks. So in your continuous integration and continuous delivery pipeline, you may be putting stuff in place so that every time a developer A makes a change, then that gets checked for common issues that your company may have seen in the past. You want to be creating secure coding guidelines, either stuff that is specific for your product space, or just following some of the common ones that are available out there. The other big one is just doing the general security training and educating others as best you can. And just to contextualize further what application security, how it manifests as issues, one common issue and one of the biggest issues for software is that they are open to what is called SQL injections. Now, of course, SQL is a popular database querying language and often used in your backend so that you can, of course, store and use your data of sorts. And what developers often do is that they use SQL for their login pages and using it as a way to store password information. Now, if you are not using proper sanitized inputs or parameterized statements for SQL, what an attacker can possibly do is that by misusing SQL syntax so that it can create a statement that automatically gets through all possible defenses, then you can easily just break into the database. And then from there, you can do whatever you'd so like, whether that be you are deleting all of the customers' informations, whether you're using that information to steal other customers' say, credit card data, or even injecting just your own data so that for whatever other purposes you may have. The other big example that comes up within application security is known as cross-site scripting. And this deals a lot with JavaScript, which is, of course, a popular language that is used throughout front-end applications. And how this works is what an attacker can do is by leveraging the script tags in JavaScript, they can, if your input is not properly checked within a website, say your website has available a comment section or something for you to allow your customers or users to have discussions in, say, a form. And if that form is not properly sanitized or checked for malicious input, say people are trying to run JavaScript script tags in it, they can store that JavaScript scripts in your server and database so that whenever another user, say user B, then comes in, that script would then get ran on the user B's side. So from there, whatever actions that the user A or the malicious user may have done with the JavaScript, they then would be able to say, for example, steal user B's cookies, which are used to store client sessions. So when you log into a website like Facebook, those cookies are made so that whenever you log in the next hour or so, you log back in easily without having to go through the login process again. But if those cookies were stolen by the JavaScript code there that was embedded by the hacker, then that hacker can then take those cookies and then use them to log into your user's, say, Facebook account and do whatever they want from there. And another big issue that is more common within large organizations is developers, when they are checking in code into GitHub, they often leave some things they shouldn't have. Now, I don't have quite handy a cool visual for this one. As to be frank, that would be a bad idea, as I would be showing you exactly how much is out there on GitHub that people have left out in the open. So all I'll say for this slide is before you are committing anything into GitHub, please make sure that you do not have any sensitive API keys in there. That can include your Google Cloud. If you are working a lot with LLMs, you want to not leak your OpenAI key for someone else to use. That would be quite devastating to your wallet. If you are an avid user of AWS, you do not want people to be logging into your accounts, turning every possible service on, and racking up quite a bill that would be in the thousands within a day. And again, not to quite refer to anything, this has happened out there in the world, where people have had charges up to thousands of dollars because they left an AWS key public and someone was able to use that. And something of an odd example is Salesforce credentials and Node.js projects. Now, you might be wondering, what exactly is that? To be quite honest, I don't know either, but you can look up searches for those, and you'd be surprised at what you can find in terms of what people, again, leave in their GitHub projects. It seems crazy that, oh, professional developers are leaving secrets out in the open. Well, there are plenty of examples of products that people have made just for this exact case. So it happens more than you think. And so how does this all apply to you? Now, we acknowledge that you are under a time constraint to get something out within 2-3 days. And as well as you are dealing with a knowledge gap, and depending on the size of your team, you may not have the expertise required to do all this, and that's okay. But why we're here exactly is one, at least encourage you to think about these things more often, especially when you go get your software development jobs at either big tech companies or even your local organizations that probably need a lot more help with security, is that you can think about these more and at least bring them up so that hopefully you encourage your whole team or organization to get on these types of issues. The nice thing about a hackathon environment is that you can try to apply these skills in a pretty safe learning environment on your own projects. These aren't being quite pushed out to a production level. So no worries if you accidentally do expose a secret into GitHub. No worries if you didn't properly fill out how to do an input sanitization for SQL. And you never know. Kind of thinking about stuff like this so that you can talk about it in your pitch. If say you ran an automated scanner on your GitHub so that, and it told you that, oh, there's no security issues. then you can claim that in your presentation, and then you can say like, oh, you address these type of issues and such. And you never know, judges might be happy with that. Quick question, is there a prize available for this hackathon? And you are pitching the judges? Okay, cool. So then stuff like that is, if say you even talk about like, hey, I went to this workshop, I then considered the application security aspect of my project. That could win you some points there, just so that you are thinking about your project from a holistic angle, so that, hey, you care about your customers. Say you're making this, like Akshay said, you're making a healthcare product that's AI powered, however you'd like to spin it, so that it can help address patient data and scan through things quickly to help nurses, for example. Now, if you are doing that for your clients, or say for patients, and if you can say that, hey, the app that I'm doing is encrypts patient data so that people can easily hack into it, then you are actively thinking about the patient. And so, small examples like that can go a long way in pitches with a judge. And so within a hackathon, what you can do, and we'll go into a quick demo right after this, is you can use existing tools out there to scan your code for some quick fixes you can make, or even 100%, quote unquote, say that, hey, my code base doesn't have any issues because I scanned it against this tool. You would consider practical threats. So, the nation states out there, you don't have to worry about those, obviously, in a hackathon project. You might have to do so when you're working at Amazon, Google, Microsoft. But you can at least defend against people who are looking for something quick and easy to get into. Some people have automated scanners out there that are just trying to find stuff that are easy to get into. And then just also thinking about simple and secure coding practices so that you can implement it into your everyday development life. May that be, if you'd like to work in SQL development a lot, you're using parameterized statements so that SQL injections can't happen. A lot of that honestly falls down to making sure that special characters can't get into your inputs. That falls along the line with input validation. You want to, if you're using an API, you don't want people to be able to hit it with a script, like sending 1 million requests at it at a time. Especially if you're working, again, with AWS, you don't want people to be trying to send API requests to your AWS service 1 million times and racking up cents charges there. And always just robust error handling and password hashing, all kind of further things we'll get into later. So SemGrep is a actual company that works on application security. And so I'm just going to give a quick demo for it. And so what SemGrep primarily is that it will automatically scan the code that you allow it to, so that it can find security issues that are common out there. Now, admittedly, what it doesn't do well is find new and novel types of security vulnerabilities, but that's an entirely different story altogether. And kind of to demonstrate how easy and practical this is, and just to note that this is using its free version. They do offer an enterprise version where you can pay thousands of dollars, but that's something for you and your future employer to work out. And so what I've already done is that I've picked a few of the projects that I have had in the past on my GitHub. And one specifically was that I was looking at a Node.js project that had vulnerabilities already in it that were, it was made on purpose to be that way, just for people to experiment around with as like a security playground. Now, if I go into here, what it will show is that it will give you a bunch of information about what it found based on its kind of queries that it's already done for you. Think of it this way, is that when you would be manually reviewing your code for security issues, you follow a set of rules and heuristics that you learn from other people. But what the kind people at SemGrep have already done is that they've translated those rules into a configuration file already. They've built their own scanning tool so that it can present you all this information well. And so just to kind of see what exactly did this pick up, it told me that that program had 37 issues. So what exactly were those issues? So if I click on that, it will show that, oh, I've accidentally leaked an RSA private key, which is pretty bad because that means that a hacker can use that to then decrypt all of the information that I may have encrypted. So that's something you don't want them letting, or you don't want letting people easily do. And here, it looks like that it's picked up a few password hashes that I accidentally left as a comment. And so those can be stolen so that they can be brute forced by using common word lists out there. And it looks like it also found a issue with eval. And what kind of to summarize that, what it is in an input box, if it hasn't been properly sanitized or checked for special characters, then an attacker might be able to create a command so that they can then get in and do whatever they so wish within their program. And just to, again, show how kind of simple it is to add a new repo, if you just go up here to scan a new project, you can either do it locally. So say you already had code already in your own environment, you would just set it to scan, and it looks like it takes only 5 minutes. Or you can add it to your GitHub Actions CI/CD pipeline. What you can see here is just some of the other projects that I have in my personal repo that is not currently available to be scanned. But say I wanted to scan this skill secure code game thing. All I had to do is click on it, go to edit up here, add a CI job, click the commit file, give it a few seconds. And now it's already starting to get scanned. So pretty simple. Even right after this, you could sign into SemGrep, integrate your GitHub account with it, and then just leave it running, see what it finds. So I know that's been a lot so far, but does anyone have any questions they want to ask or any comments? Cool. And now just to go over some resources that you can refer to when you're working on security stuff for your software, is there's a common framework and organization known as the Open Worldwide Application Security Project. People just commonly refer to it as OWASP. And what they have is they have a top 10 list of issues that software developers are reported to have a lot. They had a top 10 list in 2017. They've since updated in 2021, and I believe they're working on a new one for 2024 to be updated and released in September. And a lot of these are honestly security technical jargon that can be broken down into more simpler terms to understand for a developer. And so say if you look at the 2021 list, the first one, it is broken access control, which is just a broken login page and hackers being able to get into that. Other things, including cryptographic failures. One thing I really want to iterate and reiterate later is do not implement your own cryptography if you're trying to do it for your own data. People with specific math or computer science PhDs who have specialized in cryptographies are maybe the only people who are qualified to write their own cryptography implementations. Otherwise, what you can do is just use something else that already people have made. People who have written their own cryptography often have some flaws in there that makes it easy to be broken, and then for your data, encrypted data, to be decrypted pretty easy. And just to kind of demonstrate these lists a bit. go over that after. Yeah, that'll work better. Okay. Another resource that you could refer to later is that the same organization has the cheat sheet series, and it covers often a lot of common tools that you may already be working with, or say if you're working with a specific security implementation and you have a question about that. Say you're working with Django, they have a cheat sheet for that and how to securely manage it, say for authentication and creating something so that people can log in. Node.js, there's a cheat sheet for that. If you're working with JSON Web Tokens, there's something on how to do that securely. If you want to learn more about securely storing passwords, they have a cheat sheet for that. And say you were looking around trying to say you're working at organization X, and they told you that they often face the issue of denial of service attacks, which are people who are just trying to throw a bunch of login requests at a time so that they can just freeze things up and make your servers and websites slower than usual. And you want to learn how to create something to defend against it. Luckily, they have a cheat sheet for that too. So not to say that these are all comprehensive resources that will fix everything after you've read them, but these are easy and quick stuff to refer to. Say when you're about to go back to your hackathon project, you can quickly look stuff up, get some ideas on how to do something quickly, and then move on to your next best feature. Now, with the rise of large language models like ChatGPT, what you can do is you can run your code through it and ask if it can find any security issues for you. That's been a pretty common application for software developers, just tossing things in and see what comes out. But research has so far shown, at least, is that they are not the most accurate. And so when, I guess, doing anything with large language models, be mindful of its output and do make sure to critically analyze whatever it shows. But you never know. OpenAI might release something on Tuesday and just solve the security issue altogether. Some other ideas you can do is that you can ask it to explain to you concept you're not familiar with, another great application for stuff like ChatGPT, or you can tell it to give you some ideas on how a hacker scenario might play out. Say you're making a software for a banking company, and so you might ask ChatGPT on, hey, how might a hacker try to break in under this banking application scenario? And so what you should do after this, and some stuff that we already mentioned, is that you should be using these existing tools so that you can scan your code for quick fixes. So may that be using SemGrep, like I already mentioned. You can also look up some other possibilities that are known as a Sneak, the one where I got the application security definition from. SonarQube is another popular scanning tool. And CodeQL is for more advanced users. But what you can do with that is it is developed by people with GitHub. And so you can create your own queries so that you can look for stuff that are specific for your repo. Like I already mentioned, for your projects, you probably don't need to worry about nation-state adversaries just yet, but you can at least worry about people who are next door just trying to sabotage your project for whatever reason. And then going after some simple secure coding practices, some easy ones, setting up GitHub Actions. Those often have some pretty quick tutorials out there that you can follow step by step. You can use regex so that you can only allow for input that you define. So for example, not letting people use semicolons in your passwords. Maybe only let them use dollar signs or however, whatever other special characters you would allow. And again, to reiterate, use your own, use existing cryptography implementations and do not implement your own. Again, doing so will allow it so that people can easily find issues within your cryptography and then be able to just generate their own key from there and then decrypt everything you've got and give your back. And so this is just now we've hit the end of the meeting. And just to show you some other resources that you can look at, you can attend our workshops. It's of course already close to the end of the quarter, but we'll be starting back up in the fall, and we'll have weekly workshops then as well. Stay tuned, either through our Instagram, CyberUCI, or you can go to our website, cyberuci.com, to get more information. Or you can join our Discord, which you can access through our website at cyberuci.com. And you can find out our schedules there, get to know people, learn about some of the other activities that we participate in. Some of the other two resources that I recommend if you're interested in learning more about computer security or application security in general is you can go to pwn.college there. That is a free and open source platform made by the faculty at Arizona State University. And what they've done is that they have created a college course style security education that is more meant for the students at Arizona State University, but you can access it entirely free as anyone else in the world. And it comes with lecture videos, additional readings, as it would be in a class. But also they have, basically you can view them as problem sets or in practice so that you can get, you can apply what you learn in those lectures. You can also check out tryhackme.com, and they have specific modules so that if you're interested in pursuing security as a career, or even just supplementing your security or your software engineering position with more security flavors, is their security engineer modules. DevSecOps is popular as obviously as a buzzword you may hear, as well as with DevOps. And web fundamentals, especially if you are working a lot with websites. Yeah, he's just a list of our references that, you know, if we share these slides, you can look at. And yeah, that's pretty much it. Well, thank you for coming to the workshop. You can scan this QR code so that you can enter a giveaway, and the VenusHacks organizers will then pick someone randomly to give you a shirt. Yeah. But otherwise, thank you for your time.